In his efforts to come up with a model that would explain the movement of the planets across the night sky, the 2nd century Greek astronomer Ptolemy imagined the Earth sitting at the centre of existence. Around the Earth he placed the planets on a system of linked circles. The larger ones he called deferents, while the smaller ones were called epicycles. Ptolemy's model enabled astronomers to do a range of important things, including make sense of a strange celestial phenomenon called retrograde motion. This is where the planets appeared to stop and reverse along their paths for a little bit before continuing along their way. As Ptolemy's model explained it, the reason for this had to do with the independent rotation of the planets on the epicycle. If the speed of the rotation of the smaller circle was sufficient, there would be times when the paths of the planets would appear from Earth's perspective to go in reverse. For all of its usefulness, Ptolemy's theory was hugely complex, and the result was anything but elegant. In fact, to get the model to work at all, he had to imagine that the deferents didn't orbit Earth directly, but an imaginary point offset to one side of the true centre, with Earth offset to the other. Only then would the apparent speed of the planetary motions work out correctly. As astronomers made increasingly precise measurements of planetary positions over time, the Ptolemaic model only seemed to become less and less satisfactory. By the 15th century, the Polish astronomer Nicholai Copernicus had had enough, and proposed to improve the situation with the revolutionary idea that it was the Sun and not the Earth that occupies the physical centre. While Copernicus's revolutionary proposal was right about the order of the planets, he still managed to get a number of critical details wrong. For example, he mistakenly insisted along with Ptolemy that the orbits of the planets are circular, and this meant that he too had to keep an elaborate system of epicycles and deferents. This need for complexity was painfully ironic, because one of the main reasons Copernicus gave for coming out with a new model in the first place was how cumbersome and ugly he regarded Ptolemy's system as being, with all of its circles heaped upon circles. In the end, necessity would drive him to use the same solution. Thankfully, the correct answer came about a century later. After numerous failed attempts and painstaking calculations, the German astronomer Johannes Kepler discovered that by crushing planetary circles into ellipses, centering the ellipse on one of the two inner foci, and varying the speed of the orbit so that it was fastest when it was nearest to the Sun, then epicycles could be done away with entirely. In the light of this greatly simplified picture, suddenly things made sense. We exist in the middle of a cosmic ballet of planetary spheres that move at variable but perfectly predictable speeds on ever so slightly flattened circles.